In section 4 of chapter 3, we are now going to talk about slope and rate of change. Now, you recall in our list of formulas, formula 3 is the slope formula. And just to let you know down here, formula 2 is our slope-intercept form. And we did mention formula 1, which was the standard form. So lots of formulas in chapter 3, and hopefully you're reviewing the list to become familiar with them. Now, in example 1a, they're asking us to find the slope. Well, we're going to use the slope formula for this. So let's carefully substitute. Now I usually take our second ordered pair as the sub 2's and the first ordered pair as our sub 1's. So it's to take y sub 2, which is 7. Now in the formula there's a negative, and then we take our y sub 1, which is 5. Then we go to our x sub 2, which is 1, minus our x sub 1, which is 6. So 7 minus 5 is 2, and 1 minus 6 is a negative 5. So our slope then, and we usually put if it's negative, the negative sign by the division bar or the fraction bar is going to be 2/5. Now we might also add at this time that when we think of slope, and we didn't give you that much background, but what is slope? Well, if you're going skiing, you are going to the slopes, where things go up and things go down. So that's slope. But it's actually, again, a ratio of these ordered pairs, but it's actually y units on the top over x units on the bottom. And as we look at the y units, this is like up and down, so we say that is rise. And we say the x units this way, we call that the run. So a couple of ways to look at slope. It's a ratio of y over x, or rise units over run units. This brings us to our second example, part B. In part A, we use the formula, which is a good way to do it. But if you have the graph and you see it's going through grid lines, what we can often do is make a little right triangle. And there's a right angle right there. And this line would represent the rise. And this line would represent the run. And we want to find out what that ratio is. Well, we're going to start here, and we're going to go down in a negative direction. So 1, 2, 3, 4, 5. So this would be like a negative 5 going down this direction. And then now we're going to go in a positive direction. 1, 2, 3, 4. So we can then write this. Our slope is a negative 5 over 4. Or write it as a negative 5/4. Now, suppose you started here. Well, this would be a -4 then in this direction, and a +5 in this direction, would still give you the same results. And we might start to look at that if a graph is high, and as you go to the right, goes down, that will always be negative slope. All right, let's use the slope formula for this. And you might say these are friends now. This was your x-intercept, and this was your y-intercept from the previous lesson. But let's put it in the formula. M equals -3 minus 0, and then 0. Now this is a little tricky because it's a negative, but now the value for x here is a -5. This negative comes from the formula, so the opposite of a -5 will make this a positive. So when we write that out, this is going to be a -3 over 5. So our slope then, and we usually put the negative by the division bar, 3/5. So before we change this, just a quick review. We've looked at the slope formula. It's a ratio of y units over x units, rise over run. We can use this formula if we have 2 points. We have to carefully substitute, and we end up with the slope. If we have a graph where it intersects the grid lines, we can make a right triangle and physically pull from our diagram what the rise is here and what the run is, and make a ratio that way. And again, just using the slope formula, figure out what it is, being careful that there's a negative sign in the formula. Now, we're going to be introducing this, and we may have already, the slope intercept form is one of the equations where we have y equals something. And we see in this formula that the letter m is the numerical coefficient of the x. And we've defined m as the slope. And we've also defined b as our y-intercept. So when a formula is in this form, it will tell you what the slope is and will tell you what the y-intercept is. So some very good information from this slide. Let's go. Now here in example 2, we're asked to find the slope of each line. Well, I'm also going to say and the y-intercept. Which is our b. So how do we do that? Well, here, this equation is in standard form. So we solve for y. Y equals, transpose the x. So our slope here will be the numerical coefficient of x, which is a -1. Now remember, every number is over 1. So in a sense, our slope is -1 over 1. We write it, though, as just -1. Again, we have to solve for y. We transpose the 3x to this side becomes a negative 3x plus 8. So our slope then is a negative 3. And again, that's over 1. We don't write the 1. Now these equations were in standard form. So this is in standard form, and we want our y to be positive. So I'm going to transpose the y to this side. It's okay to do it that way. So we have 11x. Transpose the 33 on this side becomes a negative 33. Now we solve for y by dividing each term by 3. Now I can bring the y back on this side. This is going to be just a 1y, and this is 11 thirds x minus 11. So our slope here is 11 thirds. And once again, it's in standard form. Solve for a positive y. Transpose that. And our slope here is a negative 9. Now I added the y-intercept. So what is the y-intercept here? Well, it's what's in the b position. 12, an 8, a negative 11, a negative 12. Now remember, that is what b is, but often they'll ask you in the form of 0b. If you just said 12, they may not accept it. They would want this one as 0, 12. That's the official way to write the y-intercept. If they just want the b, then you've done it. Now keep in mind, as you do your practice and your quiz me's, you're learning how MathLab wants you to enter your answers. When you put your work on your blue sheet and you indicate that your y-intercept is 12 and they wanted it this way and you only put the 12 in there, I'm able to give you partial credit for that because you knew the answer, you just had a slight difficulty in putting it in the MathLab the way they wanted it. Okay, let's go on. A little background as we go on. Suppose you were working the slope formula and your answer came out like this. You had 0 divided by 7. Well, 0 divided by any number other than 0 is 0. So the slope of this would not be 0 over 7, it would be 0. And what kind of line did we say that was? That was y equals b. A horizontal line, the slope is 0. And suppose you got this, 7 divided by 0. Well, anytime you got a result like that, where your denominator was 0, this we said is undefined. And this would be an equation, x equals a. This is the vertical line. So anytime you have a vertical line, the slope is undefined. Why? Because when you did the calculation, it ended up 7 or some number over 0. Here, when you did the calculation, you had 0 over 7. This is the slope of a horizontal line. This is the slope of a vertical line. So, for number 3, when we solve for y equals negative 5. What's the slope of a horizontal line. This is y equals b. It will be 0. Now here we solve this. 2x equals 7. X equals 7/2. X equals a. This is going to be an equation of a vertical line. What's the slope of a vertical line? Undefined. Again, these are notes that as you take them, you look at them and review them. Look at your list of formulas. We're calling this formula 5, and we're calling this one formula 6, just as a reference. All right, let's go on. A little background here, formula 7, or hint number 7. If the slopes are the same, but the y-intercepts are different, that is, they're not equal to each other, we say the lines are parallel. So the same slopes, different y-intercepts, lines are parallel. Now here, if we multiply the slopes together, and the product of them is a -1, such as the slope of the first being 1/2, the slope of the second being a -2, multiplying these, and this is the negative reciprocal of this, you get a -1, then the lines are perpendicular. So this is what they're asking us to do here. Which are parallel, which are perpendicular, which is neither. Now in your homework log, and as you do these, and eventually on your blue sheet, how do you show the work of this? Well, the main thing is put them in y equals mx plus b, that is slope-intercept form, so you can physically compare the slopes. You're going to do this for this equation and this equation. If the slopes are the same, but the y-intercepts are different, the lines are parallel. If you find the slopes and get the product of the slopes as -1, the lines are parallel. I'm sorry, perpendicular. Got carried away. The lines are perpendicular. And then all others would be neither. Now, how do you show the work that you've made this judgment? By converting these equations into slope-intercept. So we'll give you some time to do that, and you can check your work. So it took me a while to do these, but I'm showing what the end equation looks like in slope-intercept form. So here's the slope of the first one, and here's the slope of the second one. And if I multiplied these together, I would actually end up with a -1. So when we end up, after multiplying the slopes with a -1, these are perpendicular. And the proof of it is when we show the work, outline our slopes, and we get a product of -1. Now in letter B, the slope of our first equation is a -1/3, and our second equation is a -4. They're not the same. The product doesn't give us a -1, so this one is a neither. Now when we did the last ones, we found that the slope of the first equation was a -3, and the second equation was a -3, so the slopes are the same, And here our y-intercept is this fraction and this whole number, and they're different. So when that occurs, we say the equations are parallel lines. And this is the proof. And it did take a while to do that. Now, you're only going to get one on your test, so that you will, it's not going to take forever to do it. Let's go on. Now, for this next part, we're asked to find what would be a slope that is parallel and what would be the slope that is perpendicular if these are the points we're starting with. So what we have to do for each of these is first find the slope. So we'll use the slope formula, and we'll pause while we get this done. So I've just substituted, so this will become a positive. So this is going to be 4 over 4, which is a 1. Now that would be parallel. What would the slope be for something that would be perpendicular to that? Well, it would be a -1, because 1 times -1 is a -1. All right, let's do this one. So we have a -4, -10, that's a -14. This becomes a +2, so this is 7. So our slope of a line that is parallel would be a -2, and the slope of one that is perpendicular would be a +1/2. That is, take the opposite sign reciprocal of this. And we can pause and answer your questions. To set this up, and you usually get one like this on your test, you have to be careful of what they're asking. They're saying here's a ramp that is 17 feet long and has a rise of 16 inches. This little slash is a symbol for feet, and this is a double slash symbol for inches. Now, in order to set up your ratio of rise over run, we have to have the same units. So we have to multiply this by 12 to make this inches, and this is inches. So we then get 16 over 204. Now we put that in our calculator and we get a decimal 0.0784, and it goes on, and they're instructing us to round to the nearest 1/10 of a percent. So we have to move our decimal place over 2 places to change it to percent. We look at what's there and then what's there. If this were 5 or more, we'd make that 9, but not. We just drop it, so it's going to be 7.8%. And that is how they want us to put the answer into the system. Okay, that wraps this one up. It was a little bit long, but lots of stuff.